Back to what your x and your y are. In this case, our c and our x. Our c stands for, again, our what? Cost. Our x stands for the percent of pollutants you're removing. So, so here you folks found that, let's see, 120 times 80 over 100 minus 80. You had 9,600 over 20, so you all got 480. So what does that mean? What is 480? Is it my C or my X?
What's your C?
It's your C. So that means that the cost will be what?
180,000.
Thousand, right? That's a lot. To remove what?
80%.
80% of pollutants. That's a lot more. That may be worth it. I don't know. That should get your lake pretty clean. What's the domain of the cost-benefit model? So in other words, what is X allowed to be? All right, so again, what are the two things you can never, ever, ever do? Divide by zero and square root of a negative number. Are we doing anything where we divide by something with X in it?
Yes.
Yes. Does everyone see that? So what can X not be? What would make that 0?
100.
Yeah. Does anyone understand why X can't be 100? If X is 100, we'd be dividing by 0. So here, X cannot be 100. What does that mean in terms of the problem? What does that mean when X is 100?
You can't ever get 100% of the lake clean.
Yeah, you can never remove 100% of the pollutants. Right? As soon as you try to remove all of them, all of a sudden, like, I don't know, the wind blows and more leaves fall in or whatever. You know what I mean? You're never going to be able to hit 100%. It's impossible. There's always something going on.
I think it more means like you can't take out more than what's in there. Like once you take it out, it's fully clean. Like you can't go over 100%.
Well, you can't even hit 100%.
Well, yeah, I guess, but
I mean, you can't do either. You can never remove all of them. It's impossible because your function would blow up. It'd be infinite. It would cost you infinite dollars to remove 100% of the pollutants. Okay, is it possible to remove all the pollutants? No? Why do you think it isn't?
Because it's a never-ending job. It's
Yeah, I
always
mean,
being
yeah.
polluted constantly.
Yeah, there's constant pollution going on, something like that, right? Whatever you want to put. Okay. So we're going to analyze it graphically and numerically. So which means that we're going to, what I need you folks to do is find these numbers here, and then we'll graph it. So first, go ahead and find all of those. We found 20 and 80 already. What was 20 again? 30? 30,000, so just put 30. And then 80 was 480,000. 0. Well, 120 times 0 should just be 0. So that's 0. That's easy. Costs you nothing to remove nothing, to remove none of them. But find the other 5. Use your calculators. And then we'll look at graphing those. And what do people get for 40?
80.
I'm sorry?
80,000.
80? For 60?
For which one?
180? For
Oh,
60?
for 60. What was 40?
For 90?
1,080.
I'm sorry?
1,080.
And then 95?
2,280.
And 99.
11,880.
11 million bucks, it's a lot. Okay, so, let's see, so I need to go from, my Y, my X needs to go from 0 to 99. My Y needs to go from 0 up to like 11,000. So let's see how we want to graph this. So first of all, I probably want to keep everything in the, I can keep, all my numbers are positive, so I can keep them all positive. So I'm going to draw my little lines here and here, and just focus on the positive one. And I need to go from 0 to 100, so maybe going by tens. I gotta start off with 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 would be right here. And then I need to go from 0 to 11,000, almost 12,000. So let's see what I got here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So maybe make each one of these 1,000. So 1, 2, 3, 4, 5. This is 5,000. It's 5,000 thousands. This is really 5 million. Right? This is in thousands.
That's a 1 million interval.
Mm-hmm. In thousands. This is my cost in thousands, that's quite a bit. So then this would be 1, 2, 3, 4, 5. This would be 10,000 thousands, so that'd be 10 million. All right, so then let's graph these. Everybody graph your numbers there. 0 obviously costs 0. And then we went to 20 costs 30. So each one of these is 5,000. 30 is like nothing. Right, this is 1,000 here. So 30 is, doesn't even register on the blitz. It's practically nothing. What's the next one? 80, 180, 480. 80 where it's 480 is finally half of a line. So 80 is halfway up. So does you understand what I'm saying? Halfway, 40 is halfway to 1,000. So all these guys are really small. 180, 60 is 180. That's like a fifth of the way to 1,000. 60 is 180. Maybe there. And then 40 is 80. That's also like basically nothing. So those are kind of all, and it starts off really small, but then it starts to climb. What happens at 90? It becomes over 1,000, 1,080. So at 90 it jumps to over 1,000, just over 1,000. 95, it's, so this is 1,080, 2,280, and then 11,880. So those all of a sudden starts to jump. At 95 it becomes 2,280, almost to 3,000. Very close to, oh no, it's not quite. Just over 2,000. And then at 99 it goes all the way up to here. Right, so it makes this kind of crazy, starts off at nothing. Nothing, 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 nothing. And then all of a sudden it shoots way the heck up. That's insane. Does it have a vertical asymptote? So you see an asymptote going up and down?
Yeah.
Yeah. Where is it at?
100%.
You had 100. You can never touch 100. You can get closer and closer to it, but you can't touch it. Here's my vertical asymptote. Right? It means you can get, as you get closer to 100, the cost goes up crazy high. The closer you get to 100, the crazy higher it goes. So the closer you get to 100, the cost explodes. I don't know, you put it, you know, goes up. Monumentally. It just is a crazy high amount. Okay, so is that making sense for folks? As it gets closer, okay. So let's take a look. Next one's down. How much will it cost to remove 95% of pollutants? How much does it cost to remove 95%? It was at 2080, is that right?
2280.
2280? 2280? Thousand. So $2,280,000. How much more will it cost to remove 99%? So how much does it cost to remove 99% of the pollutants?
11,880.
11,880. So 1,000 minus 2,280,000. If I subtract them, I'm going to get 0.00006. $9,600,000 to just go from 95% to 99%. That 4% cost me that much. That's insane. What's the percent cost of removing 99% compared to 95%? Well, then we divide them. Divided by 2280,000. And I don't know. Everybody do it. What did folks get?
5.2%.
5.2 amount as a percent, you gotta move the decimal over.
Oh.
So,
Oh, you move over 2 spots to the left or something?
which is 521%,
To the right.
5 times more.
Oh.
It is a lot more. So there's a question on the next page for you to answer. Which is, if you were the financial advisor for the city, would you recommend trying to remove more than 99% of the pollutants? Why or why not? Answers may vary. Tell them what you think. All right, so don't just copy down what, do not just write this. All right, so everyone write down what they think. Give your opinion. Ryan, what'd you say?
I said no, it's too expensive for little gain.
Right? Yeah, personally, I would even drop down lower. I'd be like, 90% is probably fine, right? I mean, you know, I look at that, it's like, you know, think of everything you can do with with the, like 80%, taking out 80%, that's pretty darn good. Then it's, that's 600 million I save, stopping at 80%, not going to 90%, really. I don't know how clean it needs to be. No.
Yeah, 80%'s more than enough, it's a huge,
I'd settle somewhere in this 80-90%. I might go to 90 maybe, someone might convince me, but like somewhere in there is, I can think of a lot better uses for $600 million, I think. Okay. All right, so next we'll look at memory model. Ryan, go and read for me.
Psychologists study memory and learning. In an experiment on memory, students in a language class were asked to memorize 40 vocabulary words in Latin, a language which none of the students knew. After studying the words for one day, students were tested each day thereafter to see how many words they remembered. The class average was then found, the rational function.
So you n of d equals 5d plus 30 divided by d, which is the number, n is the number of Latin words they remembered after d days. Right, so after 1 day, they'd remember 5 times 1 plus 30 divided by 1. They remembered 35, all 35 days, 35 out of the 40. Does that make sense? So that's pretty good. But after 2 days, they remember less. It kind of becomes this interesting thing, which we'll see in just a second. So find and interpret. The value for d equals 1, and then do it again for d equals 5. Everyone do that. And then write down what it means, what you think it means. So remember, n is the number of words to remember. D is the days afterwards. Everybody do number 1, A and B. So what did folks find for A? You said, let's see, 5 times 1 plus 30 over 1, and you got 35. Okay, so Shania, what was your interpretation?
35 words remembered by the students in the grade.
35 words remembered. By students. Like in 1 day, 1 day later.
Mm-hmm.
1 day later. And then the next one, Natalia, what did you get for the next one?
11.
Let's see, 5 times 5 plus 30 over 5. So that ends up being 55 over 5. 11. And what was your interpretation?
Students remember 11 words after 5 days.
Students remember, remember 11 words. What did you say?
After 5 days.
After 5 days. Good.
so does that mean that they learned an additional 11 words after
No.
5 days? Or does that mean that they lost
They
everything?
get the 40 words, and then if you ask them how many words you remember the next day, they can only remember 35 of the 40.
Yeah, I get the
And then
first
5 days later, they can only remember 11 of the 40.
one. So they forgot all the rest
Yep.
of them, they only remember 11,
Yep.
okay.
Which it kind of makes sense, right?
Yeah.
I mean, some more, some less, but on average, they kind of like found that on average, they remember 11 words.
Okay.
What's the domain of the memory function? What's my domain? We can never, ever, ever divide by, so what are the two things we can never, ever do? Divide by 0 and square root a negative number. So is either one of those things going on with our function? N sub D at the very top there? Are we square rooting D?
Yeah,
No.
Are we dividing by D, so with D in it?
yeah,
Yeah, so D can never be what?
0.
0. So here,
X cannot equal 0.
yeah, D cannot equal 0. What does it mean in terms of this one? You know, it's like you can't really talk about the 0 days at the very beginning. I guess it doesn't have meaning. I guess you could say X can't be 0, so the function has no meaning the day the words are learned. Does it mean they certainly can't remember more than 40 words? And that becomes a little bit crazy, right? Theoretically, are they saying, is it possible to forget all the words learned? What do you think, looking at the function, assuming the function is correct? So what was my function again? It was
5D plus 30 divided by D.
what do you think? Pick a really big number. Like, try D equals 1,000. See what you get. Try D equals 1,000. What do you get? Oh, you know what? We will, right. So is it possible someone forgets all the words? Somebody might, but someone else will remember a bunch of them. So, I don't know. What did folks get when they put in 1,000? I got 5 point something really small. Anybody else get that? 5 point like 003 or something like that.
Yeah.
Okay. So so I'd say no. At least someone will remember some of them. Someone will remember some of them, the words. So even if like some people forget all the words, there'll be other people who remember, you know, maybe 10 of the words, so they kind of balance each other out a little bit. Like I still remember, you know, Agricola, farmer, from when I was 12.
Is 2 supposed to be X is not equal to 0?
Oh, I'm sorry, you're right. Thank you.
And then 2 cannot equal anything above 40 too, right? Or it can't.
Yeah, it also can't be, well, W, the function can't equal anything above, N can't equal anything above 40.
Right.
Right. So that's your range. N can't be above 40.
Oh.
Yeah. Right. So maybe, yeah, you might want to comment in there too, like N can't be more than 40. Another quick comment in there. Okay, let's hop on to the next part. So we're going to go ahead and complete these values. So we've already done 1 and 5. 1 was 35, 5 was 11. So bust your calculator, find the rest of them. And then graph them. So on the, along the graph, you want your x's to go from 0 to 100, and you want your y's to go from, from 35, 0 to 35, I think.